This problem is maximum subarray. So given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. And a subarray is a contiguous part of an array. So here what they are asking is we have one array and we want to find a subarray which should have at least one element, and we need to find such subarray that can have maximum sum of the elements of the subarray. Okay, so if you see, this is a large array, and for that, even if we want to do it, we need to find it manually. Instead of code, we have to go through lots of trial and errors. We will first try with first two elements, then we'll add third, fourth, and that's kind of a brute force approach. But there is another approach called dynamic programming, the DP solution, and we will look at the both of the solutions. Okay, before going into the solution part, let's check which are the companies asking this question. So in the past 6 months, LinkedIn, Amazon, Microsoft, Apple, Adobe, Google, these are the main companies. Okay, so now in this problem we will also learn how we can start with the brute force solution, and how can we improvise our solution. And in most of the interviews, this is what happens. We start with the brute force solution, and then step by step we improve our solution. Okay, so so the brute force solution is just looping through these elements and finding all the possible subarrays and calculating its sum. And meanwhile, we'll also keep count of the maximum sum, and at the end we'll return the maximum sum. So for that, integer max sum is equal to integer dot min value. So this is a good practice whenever we are we want running maximum sum or something. What we do is we initialize it with the minimum value of integer. So whatever we get, even if it's a negative number or 0 or positive number, whenever we check with this number, we'll get the maximum number. So this is the first for loop. So for example, if we have this array, then we will have one pointer called I, and I will point to this numbers. So for that, integer I is equal to 0, I is less than nums dot length, and I plus plus. So this is the first for loop, but to create a subarray we need another for loop, because the way we want to do is, first we'll start with -2 and slowly we'll form the subarray. Then in the next iteration we'll start with the 1, and one by one we'll create a subarray, and meanwhile we'll also keep counting the maximum sum, and then we'll start with the -3 and create a subarray. So there will be another for loop, integer j is equal to I, because we want to start from wherever I is, and j is nums dot length j plus plus. Okay, so we have two subarrays, we have two for loops, and we need to keep counting the sum of a subarray. So what we can do is integer sum is equal to 0, and here sum equal to sum plus nums of j. So we'll keep adding all the elements which we are seeing at jth place, and we'll add it in the sum. But with that, we'll also keep track of maximum sum. So maximum sum is equal to math.max. This is a simple Java function called max. We can pass two values in this function and it will return the maximum value of those inputs. So here we will add sum and max sum. So whichever is greater, it will return, and we will store it in the maximum sum variable. And yeah, at the end we'll just return max sum. So let's first try running it. Okay, let's try other examples too. Okay, let's submit it and check. Okay, oh, 105 millisecond. It is very slow, and obviously it will be slow because it's a brute force solution. And let's first understand it clearly. So what I will do is I'll print here system.out.print, and here we'll print the jth element, and after that we'll also print some space, and just to see how many rows we are going through. And here we'll print just for the new line, we are printing this, and yeah, and let's put comma there. Okay. So if you see, we started with -2 1 3 4, so basically this whole array, and then in the next iteration we started with the 1 -3 4 -1 2 1 -5 4, and in the next iteration, oh, what one more thing we can do is we can also print the maximum sum. I hope that will be helpful. Yeah, at least yeah, we can just print it like this. So remember, the last element is the maximum sum, just to indicate it. Okay. Yeah, so if we consider the whole array, the maximum sum is 2. Then we considered this whole array, we got another maximum sum which is 4, because we removed the first -2. And in this array we might saw less than or equal to 4, so our maximum sum did not change. And in this array we got the new maximum sum, which is 6, and we never found better maximum sum, so we kept it 6. And this is starting another problem. So our solution ends here and we return 6, and that's how we solved this problem. Now this is a brute force solution, so we need some way to improve our solution. So there is one solution technique called dynamic programming, and for specifically this question there is one cadence algorithm. So before going through the solution, let's again look at the problem and try to find out some patterns here. So suppose starting with -2, currently if I go from left to right in this array, in the starting I got my sum as -2, and after considering 1, my sum will be -1, and if I add -3 into it, my sum will be -4. But after that, when I see 4, if I add it in this sum, my sum will be 0. But instead of it, if I think that instead of it, let's start from here and ignore this previous array, because it is just decreasing my sum and not increasing my sum. Say for example, our input is 1, 2, 3. So when we have all the positive numbers, we'll just add all those numbers and we'll get our answer. But the problem is, whenever we get the minus number, suppose here we get -1, our sum will become 5. Instead of that, actually no, our sum won't become 5, our sum become 4. The total sum of all the elements will be 4. But suppose if we ignore the first element, our sum becomes 5. So if we ignore the initial minus values of our array, we can get the maximum sum. That is our conclusion. And in another example, let's say our example is this one, and we got here -3, here -1. Let's try summing these numbers, because as we concluded that we are ignoring the initial minus numbers, then our sum will be 3 plus 5, 8, right? But instead of that, if we ignore all these numbers, our sum can be 9, because now we will summing only these two numbers. Now the reason behind it is the total sum of these three numbers is again negative. It is -4. So considering the total sum is -4, instead of that, what we should do is we should ignore all of those three numbers, and we should just start summing up from here. Now we'll do similar thing in code. So for that, let's remove it. So for that, let's take previous sum is equal to, so I am taking the first element of array and considering it's my previous sum, and maximum sum is also the first element, because if there is only one element, it will be our maximum sum. Now we will have a for loop, because at least once we have to go through the whole array. So that's why we have one for loop. I is equal to 0, I is less than numbers dot length, and I plus plus. Now we can calculate our current sum by adding our current value in the previous sum. Okay, so our current sum can be our previous sum plus numbers of I. But as we discussed, that if our previous sum is negative, then we want to start from here and not before it. So in that case, we can have one condition here, that our current sum can be, so first we'll check whether our previous sum is greater than 0 or not. So if it is greater than 0, our current sum will be previous sum plus numbers of I. Here we, instead of 0, we should start with the first element, because we have already considered our 0th element in previous sum and maximum sum. So numbers plus I, and if it's not greater than 0, in that case our current sum will be numbers of I. So in that case we are ignoring our previous sum and we are just putting numbers of I as our current sum. And of course, after doing our current sum, we need to check whether this is our maximum sum or not. So for that, max sum comma current sum. And before going to the next iteration, we need to update our previous sum as current sum. Let's try running it. Oh, at the end, I forgot to return max sum. Okay, so this is how it is running. It accepted our solution. Let's try submitting it. Okay, now we can still improve this problem by using some, again, this math.max function. And I also saw that we are using current sum variable unnecessarily, so we can totally remove it. So first what we can do is, we can here, instead of checking whether it is greater than 0 or not, we can just use math.max function for these two values. Ideally we just need the maximum number of this, because in a program whenever we add the conditions, basically it slows our program. So instead of that, what I am going to do is, I'll use Java function to find the maximum number of these two numbers, right? And yeah, let's try running it. Okay, let's try submitting it. Now again, to improvise this problem, we can remove our previous sum, and instead of that we can merge our previous sum and current sum variable into one variable, because keeping track of two variables seems unnecessarily in this problem. So what I can do is, I can replace it with sum. So when we start, our sum will be the first element. Now when we come here, then at that time our previous sum becomes our new sum. Now when we did that, now we don't need to take care of this thing, and we can replace current sum to sum. Again, let's try running it. Okay, we don't need to initialize it because we have already initialized it. Okay, let's try submitting it. Okay, so this seems good. Now as you can see how our improvisation works, how it affects the memory. Now here, if you see, in our first solution we were going through two for loops, which means our time complexity would be big O of n square. and our space complexity will be big of n or a constant space. But in this solution, our time complexity is big of n and not n square. So we have improved our time complexity drastically. And also in the previous solution where I was using previous sum and current sum, I was using one more variable, even though it was temporary, but it was still one more space in our memory. So we have also reduced it, and that's how we can optimize our solution and decrease our time and space complexity. So this is our solution. um, Feel free to comment if you have any better solution. Let me know. If you don't understand any part of this problem, please put it in the comments. I'll surely explain whatever is missing. And yeah, if you have any suggestions to improve my video or the way I am explaining or anything else, let me know. um, yeah, thanks for watching. See you in the next video.